Imagine having a versatile smart home notifier that seamlessly integrates into your setup, providing sound and speech notifications, two-way voice communication with your home assistant, and even the ability to enjoy music and radio, all without the need for additional Bluetooth speakers. Whether you're automating daily tasks or creating the perfect ambience, a notifier like this can elevate your smart home experience. This is the third iteration of my speaker system for my home assistant smart home application. The first two versions were overly complicated and challenging to manage. They incorporated active amplifiers, which not only proved unsuitable for my speakers but also introduced several issues. These included significant interference, the requirement for high voltage power to operate, and excessive heat generation that compromised my PLA printed cases. For the third iteration, I decided to simplify the design and focus on creating a practical, low-maintenance solution. I opted for a basic D-Class low-voltage amplifier to hook up to the speaker only when needed. This design can also run on battery power, making it much more versatile and easier to implement. The result is a streamlined notifier with just 3 small, key components. For this iteration of my home assistant notifier, I used a combination of compact and efficient PCB modules to simplify the design and improve functionality. Lolin32 Mini board or clones. This board was an excellent choice due to its integrated LiPo battery terminal, charger, and protection circuits. These features eliminated the need for additional modules to manage the battery. However, it lacked a voltage divider to measure the battery's voltage, a critical feature for battery-powered devices. To address this, I soldered a voltage divider circuit between an available GPIO pin, ground, and the positive terminal of the battery. UDA1334 stereo driver for audio output initially. I considered using a Monomax 98357 amplifier board that operates on the I2S protocol, but I didn't have one on hand. Instead, I opted for the UDA1334 stereo driver, which lacks built-in amplifiers. This turned out to be an advantage for my setup, since it allowed me to pair it with a separate amplifier module, giving me more control over the amplification process. PAM8403 D-Class amplifier board for amplification. I used a compact PAM8403 D-Class amplifier board. While it's not the most ideal choice due to its limitations in power and sound quality, it was readily available and sufficient for the needs of this project. Despite its simplicity, it integrates well into the overall design, providing enough output to drive the connected speaker. For the case design, I utilized existing 3D models downloaded for free from grabcad.com. Huge thanks to their creators for sharing such useful resources. When I couldn't find a suitable model, I turned to CAD software to create one from scratch. This process involved using PCB photos and a caliper for precise measurements. While it's not overly complicated, it does take time and effort to ensure exact dimensions. I had to carefully measure, cross-check, and verify sizes against known component dimensions, like header pin spacing and other reference points, to ensure everything fit perfectly. For the power source, I picked up an 1,800 mAh LiPo module from a local store. Conveniently, it came with a pre-crimped connector compatible with the Lolin32 Mini board, which made the assembly process much easier and saved me time. Next, I began designing the case for my future device. If you're still with me and not bored by now, I'd be happy to walk you through the process. Of course, feel free to skip this part if case design isn't your thing. Once I finalized the design, I sent it to my recently purchased Anycubic Cobra 3 Combo 3D printer. This amazing printer handled the task beautifully, and I was impressed with the print quality and precision it delivered. After printing the case, I carefully laid out all the components inside, securing them in place using double-sided silicone adhesive tape. This method ensured a clean and stable assembly without the need for screws or complex mounts. Finally, I soldered all the connections together, bringing the entire project to life. To test the device, I connected it to a passive ceiling-mounted speaker I had on hand. While the sound quality from this basic speaker wasn't particularly impressive, it was more than sufficient for its primary purposes, playing soft background music and, more importantly, delivering sound and speech notifications from Home Assistant. For a more thorough test, I also hooked up the Notifier to my Edifier R1380DB active speakers, and the results were impressive. The UDA1334 based I2S driver delivered surprisingly high-quality sound, given its compact size and affordable price. The clarity and fidelity of the audio exceeded my expectations, making it a great fit for use with higher-quality speakers. That's all I've got for now. If you enjoyed this project and want to see more, please don't forget to like this video and subscribe to my channel for updates on future projects. I'd love to hear your thoughts, so feel free to leave comments below. Your feedback and ideas are always welcome. As always, you can find the list of parts used, schematics, and 3D models for printing in the description of this video. Thanks for watching, and have fun with your own builds. See you next time.